Buona tarda, good afternoon. Yeah, I'm Pere. I work for Confluent, and I've been in many wars. So this will be some stories from the trenches about Kafka. Before we start, we are quite a lot. How many of you know Kafka? Okay, so it's not the writer, the software project. Okay. How many of you use Kafka? Keep your hands up in production. More than 3 nodes? Okay, quite a lot more than 3 nodes. That's amazing. So what we are going to do today is a little bit of review of Kafka and its internals. And I'm going to review a list of topics that basically are a collection of war stories around people operating Kafka. Hopefully we will do it on time because this talk I can be hours talking about that topic. So what is Apache Kafka? At the end, Apache Kafka is a system to connect applications. It's the central neural system of your infrastructure. It can serve to connect applications, to connect a database, a NoSQL database, to your Elasticsearch, to your stream processing, offload stuff, to a data warehouse or Hadoop, etc. It is your connection. But this is the abstract way. What is actually underneath? It's very important when we operate systems to know the abstractions that you are working with. And in the case of Kafka, it's a distributed log, per se. So what is really this distributed log? What we do, we write at the end of this log, okay? And we read from many of these points. This allows us to have a very high performance write throughput and read throughput and an easy escalation. But this talk is not about why Kafka is great and how is the distributed log, etc. It's about this. Kafka is a highly distributed system with way too many pieces. So for example, in here we can see the consumer groups, okay? What is the consumer groups? The consumer groups is the abstraction that organizes a collection of consumers on your topics. It can decide who reads what and from where. We have the Zookeepers. How many of you like Zookeeper? Okay, that's good. Only one. Maybe you are the only one brave enough to like Zookeeper. The one who has been operating Kafka or Hadoops or things like this for a long time knows that Zookeeper can be a little bit challenging. We have the brokers, and the brokers get partitions. These partitions can be a leader or a follower. But we have another very important topic here, very important component, it's the controller. The controller is the broker in Kafka that's the master of the cluster. Okay? It's the one that will be talking to Zookeeper, the one that will be holding the meta information, the metadata for your consumers and for your producers. Is a very important node here. As in any household, if you have 2 masters, you have a disaster. Okay? So in Kafka, you only want to have 1 controller. As well, we get 2 very important gentlemen here, the log compaction thread and the replica fetcher thread. The log compaction is the thread that's responsible of compacting topics and deleting messages inside the topics. And the replica fetcher thread is the thread that is responsible of copying data from the partition that's the leader into the followers. If one of these 2 is dead for any reason, you are in trouble. And trust me, in previous versions, they can die. This image is very, very important. So if you have been operating Kafka or want to operate Kafka or anything like this, put this under your desk, okay? You can take pictures, but this is going to be published again. It's open in a speaker bag somewhere. This, it is very important because it's the process of a request, okay? What the request is doing in Kafka is entering the network ports, and then it's going to a collection of network threads that are basically pulling from this and reading from these network ports and putting data into a queue. From this queue, another bunch of threads, the IO threads, it gets data from this queue and write it on disk. Not directly on disk, on the page cache, but as the responsible of doing I/O. After this happens, data is going to the purgatory. And yes, the purgatory is what you are thinking. It's an intermediate state where the message, the requests are being held captive until they are replicated to other brokers. Okay? And after this happens, in case, obviously this purgatory, this revision to other brokers happens when it's being held there when it's needed to be there. There is the response queue as well. That's a queue where when everything has been okay, the response is there, and it's queued for the network threads to get the message and respond back to the network. Why is this important? Because if the request queue is full, we are in trouble. If your I/O threads are very, very busy, no one is going to be fetching data from the request queue, so your back pressure is going to go up into having trouble for the network. Or the purgatory. If your communication to the other brokers is not working, the purgatory is going to be full. Why is this important as well? Because we get these names here. These names are from the JMX monitoring. Kafka is very, very chatty. And you can get all of this out of JMX from Kafka. Very important. You run Kafka, you have to monitor these bits here. This is the same image as we saw before, but is the description of the different components in the code base. First challenge, understanding durability. It has happened to all of us that have been operating Kafka for a long time, that we sent a message and everybody's worried. I'm going to lose my messages? Okay? This is basically about that. So in the wonderful scenario, producer sends a bunch of messages asynchronously. Partition leader receives the message and update the open segment, because Kafka always works with open segments. If more than one partition, there's more than one partition, the replication and the high watermark protocol starts. These are the bits responsible of assuring that data is moved to other brokers. If no exception, Kafka exception, is returned to the client, the producer continue without interruption. But bad things happen in distributed systems, otherwise it will not be fun to operate them. For example, in this scenario, this is a very common question that I find every day, is, can I run only one node in Kafka? And I'm like, yes, you can, but probably you shouldn't. And why you shouldn't? It is because what we do here is what we said before. We buffer the messages, we send them into the Kafka, this is only one node, we batch them all together, we have acknowledge. The acknowledge is what we're going to see later as well, is the property of telling Kafka how durable you want to be. But then this broker goes on fire. What are your producers going to do? It's going to keep retrying if you configure it. If not, it's not going to retry. And then it's going to throw an exception. So yes, you can run one node in Kafka, but probably you shouldn't. Oh no, my data is only in one node, in one server. This is a more robust scenario here, where we do exactly the same thing. And here the rectangles that we see in the blue color, they are the partition leaders, the gray ones are the followers. In here what we see is a scenario with 3 brokers, where I'm actually buffering the same thing. Very important variables to understand in this scenario here is the acknowledge, okay? Variable that I configure in the producers. It can be all. It means I want all the replicas to say I got the message before I tell the producer your message has been written properly. 1. That means only the leader needs to acknowledge the reception of the message. Okay? And then the replication starts asynchronously, but I'm already telling the producer that everything was okay. Or 0. That means fire and forget. So basically, if what I'm doing is writing clicks from the web, I don't care if I lose 5% or 10%. But if I'm running financial transactions, like a couple of our customers at Confluent, You don't want to lose your money. So then you are sure to configure this properly. Very important here is as well the min-in-sync replicas. Okay? So when you do when you do things in Kafka, you configure the acknowledge in the producer, you configure the replication factor, that is how many copies I will have from this partition, and the min-in-sync replicas. Min-in-sync replicas is the minimum number of replicas that needs to be in sync in order to be allowed to write in this topic. Okay? If you get 3 replicas and only min-in-sync replicas equals 1, only 1 will need to be in sync. But if I get 3 and I have min-in-sync replicas 2, okay, 2 replicas needs to be in sync. This means that if I do ACK is equals all, okay, I will need to copy this to 2 partitions. Why is this important? Because we don't want to lose data in some cases. Warning, the defaults are ACK equals acknowledge equals 1, replication factor 1, and min-in-sync replicas 1. This means that Kafka is ready for availability and latency, not for durability. So what will happen here? One broker is on fire. If I have min-in-sync replicas 2, this partition will still work. Remember, I have min-in-sync replicas 2, so I need to copy to 2 partitions. 2 brokers are on fire. With min-in-sync replicas 2, I will not be able to write. With the defaults, so min-in-sync replicas 1, replica factor 1, etc., I might be able to still write, for example, to the topic 0 partition 1. Okay? But I have 2 brokers off for any reason. Okay? What I get when something goes wrong is these 2 exceptions, not an auth replica exception and not an auth replicas after append exception. Okay? This tells you exactly what is happening. Remember, Kafka is optimized for availability and latency, not for durability. Okay? For durability, I need to be explicitly telling Kafka I don't want to lose messages. Durability is achieved through replication. This is basically what we already saw. The most important thing here is use please min-in-sync replicas, bitte, bitte, that in German means please. It will save your ass when you operate Kafka, okay? Because nobody wants to lose messages. Think about your use case, but generally speaking is n number of nodes minus 1 if you want to be really strict, number of nodes minus 2 if you want to be a little bit less strict. Use replication factor, minimum of 3. It means you get data in 3 different places. If you are operating a VMware system and you are only on one physical host, maybe it's not the wisest, but if you get things, for example, in Amazon or in different data centers, okay, copy your data. Remember, a very common case of deploying Kafka is a 2 data center scenario. Okay? Not the best one, but in here you need to always have a number, an even number, so 4 or 6 of replication factor. Challenge number 2, the under-replicated partitions. So basically how this works is all writes goes to the primary partition. Okay? In Kafka, you always write and read from the primary. Very, very important. In the future, this is going to change. But as of now, you only write to the primary. Once data is received by the primary, the process of replication starts. And when all acknowledge and min-in-sync replicas are copied, we will give back to the producer a thumbs up. Okay? When some partition is not in sync, it means it's not catching up with the leader of the topic, of the number of partitions. It is under-replicated. This is a very important metric. This could be normal, okay? But it's a canary. If you get under-replicated partitions, something is happening, okay? It's a thing that something is going on. Basically, what this is like this, okay? If you use the Kafka topics command, you will see like you have 3 replicas here, but the in-sync replica list is only 2 elements. This means in here that replica number 4 is not available. Again, this is very important. anatomy of a request, what might be happening, what is causing these under-replicated partitions. For example, maybe a rolling restart, okay? Where I restart brokers and I update brokers. For some time, if I put a broker down, I will have these partitions being under-replicated. So imagine this case. You are seeing an increased number of under-replicated partitions, so something is going on. You are starting to get nervous. Even a few topics are offline. Nobody can write to these topics anymore. You stop your producers, the cluster does not heal over time because this Pere told you that this might be something transitory, so you stop your producers to see if it heals. You restart the problematic nodes. By the way, if you have a Kafka broker in production, don't be so fast to restart a broker, okay? You might be fooling yourself into hiding the problem. If you restart a problematic node, then everything works again, so you are happy. But suddenly, after a few minutes, you start seeing again under-replicated partitions, so you say, I didn't fix it. The scenario is this. You have Kafka cluster version 0.11, quite old. Your network and I/O utilization, so from this funny picture that I show you, is normal. The issue does not heal by itself. Remember, under-replicated partition might be something normal. And when you look to your logs, you see this thing, offset out of range exception or fatal replica fetcher thread. Exiting because log truncation is not allowed for partition. Remember these two gentlemen that I told you that if they die, you are in trouble? Log compaction and replica fetcher? This is one of them. So what happens here is that you hit the bug that is listed here, the Kafka 5634, that was causing the high water mark offset and the topic offset to change. Okay? When this happened, the replica fetcher thread entered a state that said, I don't know what I can do now, so it killed himself. Okay? This happened by writing very quickly in a producer. So what I'm trying to say here is update your clusters. Okay, don't do like a couple of customers I work with in Germany. They were still running 0.11. No. Kafka changes quite a lot. Every now and then there is a new version. So always keep this idea in mind. Between 6 months and a year, update your cluster. All of these errors are just from the old days. Challenge number 3. Who is not interested to keep order? You are running Kafka, you put message in a queue, people will be willing to read these messages in order. Does this sound familiar to you? Your producers are sending messages to Kafka without problems. Consumers are not processing the message in the expected order. What could happen? Many reasons. So you might be wondering, there were so many moving parts in Kafka. Let's see what happens. Kafka keeps order per partition. Okay, so it assures you that every message written to a given partition is giving a new ID that's monotonically increasing. The first is 0, 1, million, million and 1, etc. We keep order, warranty this order per partition. Okay? If you have 2 partitions, messages might have different order. So what happens here is we produce messages and we want to produce them in order. So we need to be sure about very important metrics here. Delivery timeouts, linger MS and batch size to see how many messages we put together in a batch. And the most important one here is max in-flight requests per connection. Okay? If I have, the default value is 5. If I have 5 requests going parallelly to the brokers, and the second one fails, sorry, the first one fails, but the second one succeeds, they might get out of order. So if you want to keep order, you do max in-flight request per connection 1. So you only send and retry the same thing until it succeeds. Because if you send a batch of things, this can get out of order. This is what I was saying. It doesn't keep in order. Please keep your retries. Bitte, bitte. It's very important to retry on the producer side because shit can go wrong in the network. Your network team will tell you that it's the best network ever, but things can go wrong. So it's important for delivery that you keep retrial bigger than 1. And if you want to ensure order, keep maximum flat request per connection equals 1. So in case of retrials, you are not retrying things in different order. Understanding the key is very important in Kafka. The key in the message is used to target a given partition. Okay? So understanding how your key looks like and how your message is being sent is very important. I always put the same example. Imagine you're running a money broker, okay, where you send messages that relate to money, and your key is your currency. And you get euros, you get pesetas, you get dollars, but you're operating in Germany. You get a big bunch of euros, probably no pesetas and a few dollars. So you will get one partition, the one for the euros, that will be immense, while the one for dollars will be very small. Kafka likes to have things evenly distributed. So try to have always your key. That key will force you to have this order. Some of you might be wondering, this is a distributed system. Have I missed something? Yes, the consumers. Your system could have one or more consumers. They are organized by the consumer group protocol. The consumers are responsible for committing the offset. It means telling Kafka and the topic and the partition, I've read your message. I got it. No, you can't forget it about that. You can move me one step forward. There is different strategies. You can commit the offset once you have processed the message. You can commit the message after reading, after doing the poll, you commit them. You can enable auto-commit. That basically works by committing the message with a timer. Consumers will only read committed data under the high watermark level. Okay? High watermark is where the consumers can read. The question you might be asking yourself is, when do I commit my message? And if you are using auto-commit, that I would not recommend you, understand why you are using it and how you are using it, because it's a timer. Okay? Basically, we'll commit the message every 10 seconds, every 3 seconds. Okay? And this is very important, because your processing of this message can last 15 seconds, while your auto-commit is in 3 seconds. Handle retrials, because the systems will go offline when you do consumption. Embrace the idea of the dead letter queue, the parking lot. If I cannot write to my Elasticsearch because it's offline or database or queue, etc., put it in the parking lot and process it later on. Prepare your application to handle duplicates. Embrace at least once. Really. It will save your ass quite a lot. And sanity. You can have exactly one semantic in Kafka, but not by aggressively committing every message super fast. This will kill your broker. Actually, this is a true story. I had people that call me like, my broker is down. They were committing every microsecond nearly the offset. Okay? This puts unnecessary load. You can do exactly one semantic that is specifically idempotent producer. Very nice if you do microservices, for example, where the messages are being sent in order and kept in order, and in an idempotent way. This thing of speaking 4 languages every day is sort of a nightmare. Challenge number 4, having a partition reassignment storm. Okay? In Kafka, see this is a scenario. You expect a consumption, your expected consumption throughput is degrading over time. So your boss is calling you, Kafka, done run well. Your production throughput, so the way you're writing things into Kafka is still as well going down. So you decide to create new partitions, because new partitions will give more consumption process. But the problem seems to persist. What happens here? Okay, this is a very important topic. Remember what I said before? We write to the leaders and read from the leaders. So all the business is into the leaders. In Kafka number 1, we get 3 leaders, while Kafka number 2 has no leader. What means is that we don't write to Kafka number 2. He's lazy. We should do a reassignment of these partitions that make him work. Okay? The natural situation for this is to do a reassign of the partitions. You have the Kafka reassignment partitions tool in the Apache project. If you do this wildly, it means the Spanish way, con dos cojones, you will kill your cluster, literally. Especially in the old versions, there was not possibility to do throttle, okay? If you do that, do throttle, because if you remember the image I showed you before, there is only one network entry to the broker. If all your requests are for doing the reassignment of the partitions, you will not be serving your customers. So you need to keep one slide of my network for the reassignation of partitions, one slide for your customers, always. If your network processor are crashing it, everything slows down. So your network processor needs to be happy. The solution, move a small number of partitions at a time. Okay, if you get 100 partitions to be moved, move always a small number as well. This as well is interesting because, especially since version 2.1, until version 2.1, sorry, the metadata, it got stale quite a lot. It means that, especially in a high throughput scenario, the metadata, the information that tells where things are staying, it got stopped. And this is bad for rebalancing. Please use throttling. Otherwise, you give me job. But use throttling. It helps quite a lot. Or you can use as well Confluent Rebalancer. That is basically an automated tool by Confluent to do that for you magically. The moral of this story is monitor your cluster, always. I was having lunch with a gentleman sitting over there who said, every operations people put monitoring. No. There is still people who operate systems without monitoring. Kafka is very chatty. JMX will tell you everything. And every time you change your data flow, test it out in pre-production. Okay? Remember, con dos cojones, my Kafka brokers will go down. Test it out and then use it. Challenge number 5, taking care of Zookeeper. We all love Zookeeper or not. Zookeeper is the coordinator, okay? It's the housekeeper of the Kafka cluster. It is as well used as internal key value store for Kafka. What this means is that Kafka is storing there, for example, the mapping between partitions and brokers, who is the leader, some configurations, etc. If you lose Zookeeper completely, your Kafka cluster will not recover. It can recover if you recover Zookeeper, but recovering Zookeeper will be really painful. I've been in 2 things like this and it was 48 hours work. No happy. No, I would never, ever repeat that scenario. It's no longer functional because, for example, the mapping of replicas to brokers. If this is lost, the controller will not know what partitions are where. Number of nodes for Zookeeper. 3 or 5? What do you think? 3 or 5? Who says 3? 5? You win. For production, 5. Okay? Always. Why? Because if I lose one, I still can breathe, take the bus or the Renfe, it's going to be late, arrive to the office, get a coffee, and then fix the machine. If I have 3, if one dies, I cannot take the Renfe. I can take a teletransportation to fix the cluster. Always use 2n plus 1 nodes, always an even number. 3, 5, 7. Don't put more than 5. It's unnecessary, literally. The overhead in the network, it will be quite a lot for that one. And for production, please, always 5. If you're Zookeeper, better to be running dedicated hardware. It's very sensitive, your Zookeeper. Needs a lot of care. Dedicated hardware, ideally, if you have SSDs for the transaction log, if you are worried about filling the whole disk, use the auto-purge functionality. It's not memory intensive. Usually something like 8 gigs is enough for Zookeeper. We'll still be happy. For Kafka, something around 6, it is as well enough. Okay, it doesn't use a lot of heap. You should ensure Zookeeper is not competing CPU. Okay, don't do collocation. The next thing that people ask me is, can I put Zookeeper and the brokers in the same box? You could, but probably you shouldn't. This is a sentence from a colleague of mine in France. He said that, and then they made a T-shirt that it is in French, so I don't speak French. Zookeeper is like your grandmother. You put it by the fireside, you pamper it, and you put SSDs. I don't know you, but when I grow up, you take a lot of respect and care for your grandmother. With Zookeeper, the same thing. Challenge number 6, monitoring. Please put monitoring in your systems. It will help your life. This is sarcasm alert, okay? It's me trying to be funny, what I'm not. Seems to be a unanimous agreement in the community. Running distributed system is easy, okay? There is no need to observe the system, what it's doing. Why observability? We know what we are doing. We don't need monitoring. The reality is different. Without observability, your eyes are blind. Okay? This is serious alert. A distributed system, it's formed for way too many parts to understand. And Kafka is very chatty. It will tell you a lot. It will speak way too much things. Detailed list of metrics here. Okay? It tells you a lot from production, from producing rates to memory, a lot. Set up alerts. Please, monitoring without alerts is the second question. People put monitoring and then they don't do alerts. So why you put monitoring? Very, very important. If you put monitoring and you're a good operator, you monitor as well your system, not just Kafka. Very important. The file handlers, for example. If you run out of file handlers, Kafka is going to tell you, bye-bye, I'm going to kill myself. CPU, disk, I/O, network, file handlers, put it, use it. Set up alerts. 60%, I should do something. 80%, I should get the hell and fix it now. Use Prometheus, Grafana, Jolokia, MetricBit, Elastic, not necessarily all of them at the same time. For example, Prometheus and Grafana, I see it everywhere and it works very, very good. Jolokia, MetricBit, and Elastic as well. It is very, very good. So here you have 2 links with examples and a blog post from Elastic that explains how to do it. Challenge number 6, security. The next question I have after monitoring is, why do you don't put security if you are building a shared platform? No answer yet, but use it. If you are willing to screw things up with your Kafka cluster, put no security. Everybody will do what they want, and then you're going to be wake up by an end page. Use quotas. Why quotas are important in Kafka is because they kept food for everybody. If you have a multi-tenant environment without quotas, remember the network threat at the beginning? If you have one that's very greedy, it's going to get all the resources. You have to put quotas. Part of the house for everybody. In Kafka, you can do encryption as well. You can do SSL for encryption and authentication. You can do authentication with SASL, with lovely things like Kerberos if you're a brave man or girl. You can do authorization with ACLs, and please, quotas and throttle. They help quite a lot. For SASL, you can do Kerberos. I don't know your experience, but I always had a nightmare with Kerberos. It works very nicely, you put it very nicely, but when it fails, it's like oath bearer. It means OAuth 2. Okay? Don't use it in production. Never, ever. If you are thinking to use tokens for Kafka, for the authentication, write your own. Okay? The one that is in the project doesn't work. It's not secure enough. Scrum, plain. You can as well, from Confluent, you can use LDAP very nicely for a lot of companies who use Active Directory or Open LDAP or stuff like this. And you can have more than one mechanism at the same time. One for the local environment, one for the remote, one for the open, etc. So you want to succeed with Kafka. You will need to understand durability. You will need to be comfortable with the replication mechanism. You need to handle message in order. You need to do load balancing of your data access. You will need to take care of Zookeeper. And you will need to have monitoring and security. If all of this sounds terrible, like the worst nightmare in your life, consider using a cloud service. Confluent offers one that works quite well. You can scale it up and down. It works super nicely. Marketing. But it works. I mean, I know the people who run it, and literally in Europe, they're probably the best ones I know running that stuff. You can do that with your eyes closed, probably with one open so you know what you are typing. We are hiring. Okay? We are growing extremely fast. Talk to me. Questions? And I did it on time, what is amazing. Puntualitat Alemanya.
Hi, Pere.
Hi.
I have a question.
Sorry, guys. Like,
Shh, lower your voice.
Yeah.
Let the gentleman speak.
Regarding having an architecture that is based on Kafka and regarding the consumer side, would you recommend on running the consumers in a random platform like Kubernetes or ECS? And if so, what are the main challenges that the team will need to face?
Good question. If you want to start doing Kubernetes and stateless applications in the Kafka world, run your consumers or Kafka Streams application in Kubernetes. First point. Second point is usually the consumers are embedded into an application. So you will put your whole application on Kubernetes, not only the consumers.
Let's consider only the consumers. So they are consuming as much message we have in the broker, and then you have a metric that tells you which is the lack of the message, and you spin new nodes, or... For
example, a Kafka Stream application is very common to put the workers in Kubernetes. Another question is what to do with the brokers. That this will be a completely different full talk, literally.
It was more about the consumers,
consumers
and the main challenges.
You can do that. We recommend that, and it's very scalable, and it works very scalable. But usually remember, the consumers don't go alone. They go into an application. Yeah? More questions?
here at the front.
Hi. So in the case where you were saying...
It doesn't work.
Oh, sorry. Hi. So you're saying that you need 5 nodes in a production environment. Now, if one of those nodes was to go down, don't they need to elect a leader for the partition? And in which case, wouldn't you be able to have a split vote if it was then an even number of nodes?
No. Kafka works, sorry. The question is, if you recommend to have 5 Zookeeper nodes, not brokers, for production, if one dies, what happens? Kafka works by a consensus, okay? When you get 4, it can detect the majority of the votes there. It will never have a split brain, because split brains is through network partitions, but in such scenarios, the very same protocol allows you to keep electing things. What will be going wrong is if I go below 3.
Oh. Okay. Right, yeah, that answers my question.
Sort of quick explanation.
Right, yeah. No, I understand.
If you are curious, it's called atomic broadcasting.
Right.
So if you look for atomic broadcasting, you will have a very long paper of 15 pages to have your worst nightmares.
Okay.
But it's very nice. So it's very nice paper to read.
Okay, thank you.
More questions? We have time. I was running for the questions. Don't be shy. My English is terrible.
Hello. Thanks very much for the talk. Quick question on the automatic rebalancing or the lack of automation rebalancing now. So you mentioned that if there is a problem with the throughput, if I remember correctly, that could be because we have some lead. Basically, one of the nodes might not have a writing replica, I think is the term. So we can issue a rebalancing manually, and then that should probably reshuffle a little bit those partitions. Is that correct?
What happens in Kafka is you always write to the leader of the partition. It's not like in Elastic where you read to the replicas as well. You always write and read to the leader in Kafka. If you get all your leaders in the same broker, in the same box, you're going to be targeting this gentleman. There is no possibility in the Apache project to do auto data balancing, so that if one broker has majority of leaders, automatically it moves some partitions to a lazy broker. This is done through tooling. Okay, it's done through external tools where you make a plan and tell the broker, please move this partition there. And Confluent has tools to automate this on top.
I see. Okay. Because my question was going to be, shouldn't there be an algorithm that takes care of that?
Yes, there is tools by Confluent to automate that process. But from the Apache project, there is basically a tool where you can put a JSON that says, please move partition 1 from broker 1 to broker 2.
Got it. Okay. Thank you.
More questions? We have a minute.
Yeah, I think it will be the last one, so...
If you are shy, you can stretch my neck or you get...
Come on.
You will find myself on the internet.
Don't give ideas.
Hi. So, considering...
Okay.
Considering Kafka and other messaging options, I mean, Kafka is much more than messaging, but in some cases you can compare with, for example, RabbitMQ. Which would be your advice on at which time with which conditions or team organization, etc., you would recommend using Kafka over other solutions? Because obviously it's much difficult to maintain for all your explanation, obviously.
That's a very good question. The thing I've been seeing in my trajectory is naturally it forms a center of excellence for Kafka. So it starts by a small team that does something, and it grows organically out to a center of excellence with a bunch of people work together into providing this support. Having said that, you compare it Rabbit with Kafka. In my own experience, and that's why I started at the beginning with the abstractions. I like Rabbit, and if at your organization you're using Rabbit, like at my previous employer, well, Geek, because I was a freelancer before I joined Confluent, pivotal shop, everything pivotal, great, Rabbit work super gently, but the abstractions. In Rabbit it's very versatile, you can do a lot of things. In Kafka it's a distributed log. Everybody can understand a distributed log. It's like a graph database. Everybody can understand nodes and edges. So you will find your people, your colleagues, your developers, your operational people understanding the abstractions faster than with Rabbit.
But in terms of organization, I mean...
Yeah, I said before.
How big should be the team in order to adopt it?
Big. That's something that we are working internally with a few of my colleagues to document that, but I've seen teams of many sizes. Obviously not 2 people, but I've seen teams of varying sizes. And organically what happens is this. You start by one small project that says, we're going to try out Kafka, it succeeds, and it starts growing. Start spreading to other parts of the organization, etc., etc. One team that I remember right now, for example, is 3 people. It's probably the smallest I know. But 3 very knowledgeable people. They know a lot more than what I know in databases, systems, and all that stuff.
Okay, thank you.
Okay, so I think now we have